Hello, and thank you for joining me. You're here with Data Science Teacher Brandyn, and today we're going to talk about the architecture for the deep forward network in Tensorflow. Okay, so here, really just using the dense layers, a fully connected network still, but a straight, long, deep forward network. So just still technically kind of a simple network, but now the problem that we find, or that I found when I was building this, is that when you have long networks like this, they're hard to get correct. It kind of feels like they're balancing, and they're very easy to fall one way or the other way, and it won't work when you do that. So I just added, we have 11 hidden layers here, and I just kind of mixed up the activations, nothing really super special, just to kind of show that they don't make a huge difference. When I was tracing this, just to highlight, I had to play with the learning rates because I used a 0.001 or 0.0001 learning rate, which is more typical. It just wasn't enough errors to pass back to the network for it to really learn anything. And so even at the learning rate of 5, we can see here the errors. It was still really, it didn't learn. You can see it just keeps going forward and go forward. Excuse me, it's deep forward. I apologize. I'm going to change the names here. So apologize about the name, but that was a deep forward. Okay, so deep forward, and you see it's not learning in any specific way. Really, nothing's really happening right there. Okay, so then here, going again, and what I did do to try and find the network, I just put in a very simple loop, uh, the model building, just to try test. So I tested everything. I tested the neurons, activations, and then finally found out when I got the combination that it started to work well. Okay, so it was very tricky to find with such a long network. You're going to find that there's a kind of a golden type of architecture that can be tricky to find. Okay, so here what I did, this is kind of a good simple way, just doing a loop. So I'm building my model, okay, and I'm looping through different learning rates, and then as I compile my model, I'm going to pass the different learning rates here. Build the model, train the model, print out the plots, and then just the titles right here. So I apologize, it says in deep DO forward in spelling mistake. It should be neurons, it should be learning rate at this point, but I did try the neurons first. So sorry, I apologize for that. Be diligent and change the titles of my plots. But here what we're doing, so you can see I tried lots of these and tried the different learning rates, and I kind of got the same images. Lots of them, none of them are really working. And I get a little hint that maybe 12 neurons was working better, which I settled on 12 neurons was working better. The ALU activation was working better. And it was when I started trying the learning rates, so 0.01, you can see nothing happens, but you see 0.001, 0.0001 worked well. Well, it took a little while for it to get started. It didn't look like it was learning at all until it got to about epoch 40, and then it actually started to learn. So it's taking a while for this one. 0.00, point, the -5, E-5. It's learning a little bit, but not really. And then you can see here it just kind of stops with the smaller learning rate. So you really didn't need a higher learning rate, but you can see here a learning rate of 1, a learning rate of 0.1 didn't really work super well. And this is how I was able to find this. This is a good kind of learning lesson. This really long, deep forward network can be very fragile, kind of like balancing on top of I don't know, a rope, and anything can knock it one way or the other. So there's really kind of this golden architecture that we need to find. And this is a good way to do it just with a simple loop, looping through your different hyperparameters and really finding the magic kind of set that works really well. Okay. So thank you for joining me today, and I will see you next time.